understand them still. Okay. All right, so here we go. So do you understand what's happening? They're going up and down and up and down, right? And our ordered pairs, we're going to write some ordered pairs. Not worried about labeling them right now. I'm going to write some ordered pairs. And what is X going to represent, or the first coordinate? Time. And that unit is what? Seconds. Okay, and what does this Y represent, the function value?
Height in inches.
Height from the ground. Is that right? Height from the ground? All right, so here we go. Let's look at what's happening. At time 0, the distance between the top of Steve's head and the ground is 24. Isn't that an ordered pair? 0, 24. Okay, now what's happening? At his highest point, Steve's head is 60 inches above the ground. He goes all the way up and back down on the seesaw every 3 seconds. Okay, so let's just stop a second. If at 0 seconds he's 24, when is the next time he's going to be at 24? 3:24 and 6:24 and so on, right? This is a periodic function, we're repeating. Now, at his highest point, he's 60 inches above the ground. What is going to be the time that's going to go with the 60 inches? 1.5. Does everybody understand why that's 1.5? Because 0 to 3, that's at the peak is going to be at 1.5, halfway between, right? So let's, when's the next time we're going to have a peak then? We have a 1.560, and then we'll have another one at 4.560, and so on. You could list as many of those as you wanted. Now, we have to put those on our grid that he has done and labeled for us. So we have point F and G and J and K and P. Now think about this for a second. If I extended this line down here, could that be my point 024?
Yes.
That could be the beginning. And then this would be the point 324. Does that make sense to you? And then right here, kind of the top of the hill, that would be the point 1.560. And this would be the point 4.560. Are you staying with me here? So then we need what's called the midline, that middle there. Well, let's see, can we figure that out? What would this one be? I know it's not one of our labeled points, but what would it be? 0.75, comma. What do you think?
Oh, not
18, that doesn't really make sense. 42. Guys, don't we need to be halfway between 24 and 80, or 24 and 60? And how do we find the halfway? How do we find the midpoint? We average. The average. So we added them and divide by 2. Perfect. All right, so then what's this one going to be? I know it's going to be 42, something comma 42, as is this one. What will this X value be? 2.25. And then this X value will be 3.75. Now, does everybody get those points? That is exactly like the one in the homework. And some of you missed a bunch of those points in the homework, but you got it? You okay with that? All right, let's quickly answer the last two questions. We're looking at point F and point G. So we're looking at this part of the curve right here. Which of the following is true about the function? D is the function itself. What's true about that picture right there? Well, is it positive? Yes. Look, your function values are 60 and 42. You're positive. Is it increasing? Nope. So it must be B. It's positive but decreasing. The function is going down. Now, tell me about the rate of change of that section of the curve. It's decreasing because the curve is concave down there. And it's also, the rate of change is negative. Because what's rate of change? Slope. That slope is negative. Negative and decreasing. Concave down. Perfect. Xander?
So where is T1 and T2 like on the graph?
F and G, right here. 1.5 and 2.25.
Oh, I see it now. Okay, sorry.
Okay, all right, turn it over. There is another one that is exactly the same type of situation. See if you can figure out your points. And then answer the question about whatever they asked them.
So basically, the center of the wheel right here is 30 inches away, and the side your left is 30 inches away. When it's at the bottom, it's 15 inches away. So that means the distance between the edge of the wheel and the center is 15. So then I'd add 15 to 30, the total height. And that's at the top, it's 45 minutes from the ground. And then for the time, because it's
Okay, let's talk about this for a second.
one rotation is a fourth of a second.
This right here would be one spin of the wheel. Would you agree with that? How long does it take the wheel to spin one time? 0.25 seconds. So if this is 0, this would be 0.25, and this would be 0.50. Does that make sense to everybody? Now, if this is, I'm looking at X now, if this is 0 and this is 0.25, what's this one gonna be, the top of the hill here?
0.125.
0.125. And then this would be,
Same.
no, the Y will be the same, but the X will be 0.375. Okay, what are the X's on the midline then? These X's would be what? Point. What is this one? This one is a 0.18. This one would be 0.0625. Oh gosh, I don't know. My arithmetic's not very good. Yeah. And then what's this one? 0.1875. And this one? 0.3125. How do those look to everybody? Are you okay with those X values? Might have been easier to use fractions, but oh well, we got this. Okay, so now let's talk about the Y's. At the beginning of the problem, how high is point A above the ground, or above the, whatever this is?
15.
So this is gonna be 15. And this is gonna be 15. Everybody okay with that? Now, how about at the peak?
75.
How about when it's clear up here, how high will it be? 75. And how about when it's on the midline now? 25. Now, you may have done that a little bit different way, but are these numbers making sense? Are you okay with those numbers? Okay, then let's answer the last two questions. Now we're looking from J to K. So looking at this part of the curve, is the function positive, negative, increasing, decreasing from J to K? Positive and increasing. The curve itself is going up. Now, what about the rate of change? The rate of change is also positive and increasing because that part of the curve is concave up. All right, you feel like you have a grasp on that? Next time I see you, which is tomorrow, we're gonna have a little quiz with a problem like this on it. Yay, excited about that? Good deal. All right, so everybody's ready for that. Okay. Now,
Ready
I want ready and excited. Can't beat that. Okay. Now, I want to look at a little extra practice for what we talked about yesterday. We just kind of started scratching the surface yesterday of some really important stuff. Make sure. Got this under control. So, sketch the angles in standard position. Now, I want to remind you from yesterday, all the way around is how many radians? 2 pi. So, can label our axes like this. Is everybody okay with that? And then we remember that since this is a half, right smack dab in the middle would be a fourth, right? Half of a half. So this will be the 1/4. This will be the 3/4. This will be the 5/4. And this will be the 7/4. So in other words, 0/4, 1/4, 2/4, 3, 4, 5, 6, 7, 8/4. Does that make sense to everybody? Now, we not only mark, because our special angles are 30, 60, and 45, these are the 45s. Now we're gonna mark the 30s. Now, 30 is a 1/6 of 180. So now we're gonna mark the 6ths, okay? So here would be a 6, probably up a little bit more, but doesn't need to be perfect, but here would be pi over 6. And then his image over here would be what? How many 6ths is that guy gonna be? 5? Yep. And then here, what's this one gonna be? 7, 6, good, 1 and a 6, 7, 6. And then here would be 11, 6, perfect. Those are the 30s. Now we're gonna mark the 60s. 60 is a third of 180. So we'll put pi over 3 here, 1/3. Bigger than a fourth, less than a half. Now what would the image over here be? Okay, so this is a third, this is a third. So what's this? 2/3. Because that's 3/3. How about down here? What will this one be? 4/3. And its image over here would be 5/3. Now, this, if you get this, then all these problems are easy. The first one says mark pi over 3. I'll mark it right there. That's pi over 3. The next one says 5 pi over 6. Well, that's right here. 4 pi over 3. Pi over 4. How about 2 pi? That was a little odd. Where are you putting 2 pi? Right here. Right there. Same as 0. 7/4. 2/3. Oh, I don't think I have that one. That's 3 pi over 4. Oh, what about 3 pi over 2? Where's 3 pi over 2? Straight down, right here. Same as 270. And 7 pi over 6. All right, you okay with that? All right, now flip it over and it's the backwards. Now the angle is drawn and you have to figure out the angle itself, the measure of it. So take a minute and see if you can fill those in. Your answer will be one of these numbers. One of these will answer each question, okay? she's done, no lunch. All right, here we go. What'd you come up with? Number 10.
7 pi.
5 pi over 6. You are wonderful. Number 11. Pi over 2. Number 12. Pi over 4. 13.
2 pi.
2 pi over 3. You guys got it. You're doing great. What about 14?
11 pi over 6.
11 pi over 6. 15. Pi. 16.
2 pi over 3.
2 pi over 3. And 17.
Pi over 6.
Pi over 6. Okay, so we're gonna go ahead and go to lunch. You need to be back at 12:30 in your seat at 12:30. Yes, go ahead. And never say I never gave you anything. I'm giving you 2 extra minutes. Girls, let's get a quick picture.
Okay.
Who will take our picture? Josie will take it.
So like back to back or
I
like?
don't know, what do you think?
What do you think? Yeah, yeah.
And then we can get home points. Everyone's
Yeah. That's a year.
Thank you.
Can we get one on Addie's phone?
Oh, yeah.
Oh, sure.
Oh, sure. I'll do another back to back.
Oh, yeah.
Yeah.
Thank
Awesome.
you.
Thank you for letting us borrow
Yeah,
these.
thank
Like,
you.
everybody's like, oh, I know who you are.
Oh, wait, I need
Okay, now make sure I get it back, okay?
Yeah, I
Okay.
think I'm gonna change at lunch.
Yeah.
Oh,